Hello again, everyone. Mr. Cruze here with another Algebra 2 review for you. This time, the Chapter 11 test, Part 1, of course, sections 2 through 4, as well as the samples section, which is not in your textbook, right? We'll do the second half after this eventually. But remember, your test is tomorrow, May 3rd. Great day. Iron Man 3 is coming out. So don't stay up too late, but make sure you're studying, okay? So here we go. A class tossed coins and recorded 161 heads and 179 tails. What's the experimental probability of heads and of tails? Well, okay. Let's do heads first. Experimental probability just means what's the probability that they actually did the experiment. Okay, so what were their experimental results, right? So first I probably need to add up how many total flips they did. So I take 161 plus 179 and we get 340. Yes, their teacher made them flip a coin 340 times. Out of those, 161 were heads, so you just get a percent, 161 out of 340, which is 47.4%. I would say just go one decimal place on these, on all of these. That should be right as rain. That means what's the percent of tails? Well, that's 179 out of 340, which I believe gives you, oops. Of course, make sure you actually type all of your zeros in your calculator. 52.6%. And of course, what should these probabilities add up to? 100%. If they don't, you did something wrong. Okay? Number 2, a jar contains 30 red marbles, 50 blue marbles, and 20 white marbles. I pick one marble from the jar. What's the theoretical probability of picking a red or blue? Well, or means add. So you might want to write that. Or means add. So probability of red is 30 out of, let's see, 100 marbles, plus probability of blue marble, which would be 50 out of 100. Now, technically, if you remember this formula, the probability of A or B, you have to add A and B and subtract any overlap, A and B, right? But there is no overlap. There are no marbles that are both red and blue. So 80 out of 100, which is 80%. Piece of cake. Number 3 is using this spinner over here. 12 equal sections. What are the following probabilities? First, what's the probability that we get a prime number? Well, let's think about what our prime numbers are. Just for your reference, 1 is not a prime number. 5 is. 13 is. 2 is. 2 is the only even prime number. 11 is. And 7 is. So of those 12 sections, how many are prime? 1, 2, 3, 4, 5 out of 12, which is what is a percent? That would be 41.7%. Okay. Probability of not 5 and not 7. Basically, what are the chances that I spin on the spinner and I don't get a 5 or a 7, right? I don't want to land on a 5 or a 7. Well, there's only 2 of them on there, so that'd be 10 out of 12, which is 83.3%. Okay? Probability the number's less than 6. Well, how many numbers are less than 6? We've got 1, we've got 5, we've got 2, we've got 4. So basically 4 out of 12, which is 33.3%. Probability of not prime or odd. Okay, so this could be a little tricky. First, let's do the probability of not prime. Well, 1's not prime. 15's not prime. 18's not prime. 6 isn't. 8 isn't. 4 isn't. 9 isn't. So 7 out of 12. Plus, what's probability that's odd? Okay, well, let's figure out how many odds we have. 1, 2, 3, 4, 5, 6, 7. But you have to subtract out the overlap. Any numbers that are not prime and they're odd, well, that would be 1. It's not prime, but it is odd. 15 is odd, but not prime. And I think there was one more. 9 is odd and not prime, so that would be minus 3 out of 12. So you get 11 out of 12 when you just add the tops, which is 91.7%. So far, so good. Number 4 uses this nice little platter of shapes over here, of heart, stars, and sure. Probability of drawing a black one or one that has 5 points. Well, first off, how many black shapes are there? 1, 2, 3, 4, 5, 6 out of, I think there are 10 shapes, right? Or means plus. How many of them have 5 points over here? Well, 1, 2, 3, 4. But I have to subtract the overlap, the ones that are both black and they have 5 points, which is 1, 2, 3 of them. 10 minus 3 is 7 out of 10, which is 70%. All right. Probability of gray or has 4 points. Well, there's 3 grays. Okay. Clearly, this is the American version of gray, right? 3 out of 10. It has 4 points. Let's see, 1, 2, 3, 4 of them have. That is correct. How many of them are gray and have 4 points? Well, that's just this one right here, so minus 1. So we get 6 out of 10, which is 60%. Easy enough. Very little difficult calculations here, right? At a picnic, 10 diet drinks, 5 regular drinks. There are 8 bags of fat-free chips and 12 bags of regular chips. We grab a drink and a bag of chips without looking. Okay? So obviously these are independent events. They have no bearing on each other. What drink I get does not affect and is not affected by what chips I get. So what's probability I get a diet drink and fat-free chips? Well, and is going to mean multiply in this case. Well, diet drink is 10 out of 15. Why 15? Because there are 15 total drinks. Times probability of getting fat-free chips. Well, that would be 8 out of 8 plus 12, which is 20. Okay. So you get 80 over 300, which is 26.7%. Okay. What's probability you get a regular drink and regular chips? Well, regular drink is 5 out of 15 times, what's probability getting regular chips? Well, that'd be 12 out of 20. So you get 60 out of 300, which is 20%. So we're a little more likely to get that terrible diet drink and the fat-free chips. A month is selected at random. A number from 1 to 30 is selected at random. Are these dependent or independent events? Well, let's think about it. I'm just going to choose a month at random. We'll just go with September. It's a good month. A number from 1 to 30, we will select 5. Do those two have anything to do with each other? Nope, they're independent. It's tempting to want to say they're dependent because you think 1 to 30 would be the days of the month, but that's not true. It's just a random number. Okay? Q and R are independent events. Well, if they're independent, then that means probability of Q and R is just the probability of Q times the probability of R. You're just going to multiply them. So you take 0.6 times 0.9, and you get 0.54, which is 54%. S and T are mutually exclusive, means they can't happen together. So there is no overlap. So when I go to find probability of S or T, I can just go ahead and add their probabilities because there's no overlap. So 12% plus 27% is 39%. As you can see, these problems do not take very long. Do not rush through them. Okay? Take your time, check your answers. You will have plenty of time. 49 minutes will be a long time. Okay? Let's use this table and we'll finish up this video. We have high school diploma versus not high school diploma compared to if they have job experience or no job experience. So, probability of having a diploma. Well, first, I'm going to add up the number of people that have a high school diploma. So I take 54 plus 27, and I get 81. Out of, well, how many people total are on the table? That would be 90. Okay? So you get 90%, which is a pretty easy answer, right? Okay? Probability of diploma and experience. Well, first off, how many people have a diploma and experience? That would be 54. Out of, how many people are on the table total? 90. So 54 out of 90 is 60%. Okay, these are where these get fun. Probability of experience given diploma. First things first. Let's look for the probability of having experience and diploma. How many people have experience and the diploma? Well, that would be this right here, 54. Out of the entire number of people that have diploma, okay? Remember I told you in class, what's after this bar is what goes on bottom. How many total people have a diploma? Well, again, add up these numbers. 54 plus 27 is 81. So basically, out of the 81 people who have a diploma, 54 have experience. So that'll be 66.7%. Same thing here, probability. Let's look for the number of people who have no diploma and experience. So no, yes, that'll be 5. out of the total number of people who have experience, which is 59. So 5 out of 59 is 8.5%. Okay? All right. As usual, if you have any questions, you can always follow me on Twitter at Mr. Cruze Math. You can email me, cruze@brownsburg.k12.in.us, or you could certainly post comments on this video. All right? Good luck studying. I'll be here in the morning. See you guys then.